Hello and welcome to Easy Classroom. For today, we will be learning encoder circuits. Now, what is an encoder circuit? It is a circuit that will allow us to convert any number system into binary system. So, let us consider the key points that are to be taken care of before we can understand this encoder circuit. So, this encoder is a combinational circuit, as we all know, that is, we are actually reading or learning combinational circuits. So, it is a combinational circuit that will take n inputs and will give out n m outputs, right? Relations between this input and output is like this. So, if we can consider that n to be 4, so 4 can be written as 2 to the power 2, so it will be like m is 2. So the output lines will be 2 and input lines will be 4. So that justifies our usage. The first usage, it actually minimizes the output lines. The minimization of output lines that we can see over here, it can also be done using multiplexer circuit where only one output is there and several inputs are there, right? The second use that we can find is in telecommunication. It is used in telecommunication, as we have already said, that it can be used in binary converters. We can use it in networks and in data transfers. In these four cases and in many other cases, these encoder circuits are generally used. Now, if we can consider this, what are the types? There are 3 to 4 types, but we will be learning only the first two. This is decimal to binary encoder and octal to binary encoder. In both the cases, what we are actually doing, we are actually taking everything into binary. So that is the binary encoder, binary converter. It actually converts any number system numbers to binary number systems. So now we are to learn what are the things that happens inside an encoder circuit. Now, if you can consider this encoder circuit, okay, this is a block diagram of the circuit. As we know, this is how block diagram works. So we actually need to find from which number system it is coming and to which number system it is going. So we know that it will be like in binary forms. So in binary, how many bits are used to represent that particular number in that particular number system? That we need to understand. Say for example, we have a number system of base 10, that is decimal number system. Okay, so base 10 decimal number system, say for example we have 5. Okay, or say for example we have 8. Okay, so how many minimum numbers are there to express that in binary number system? So 8 can be represented in one bit, no. In 2 bit, no. In 3 bit, no. In 4 bit, it can be represented. How it can be represented? It could be like, this is how 8 works. Okay, since we have learned that is 8:4:1 ratio, so the numbers that are here are the output combinations, the number of outputs that this encoder will pass on. So there will be 10 numbers and there will be 4 outputs. There will be 10 number of inputs and there are 4 number of outputs that this encoder can pass. That is, this encoder can pass. Okay, say for example we have 7 in decimal. So in decimal, if it is 7, so decimal number spans from 0 to 9. Okay, that means base 10. That means in 7 we can be represented as 0, 1, 1, 1. This can be represented. This is how it can be represented. So in decimal to binary, while we are actually transferring this in decimal to binary, we will be actually sticking onto this 4-bit, because in subsequent forms we gonna need this 8 and this 9 also. Okay, so we need to stick into this form, this 4. Okay, in octal to binary form, we can represent it in 3 bits, because octal has maximum limit of maximum output combination of 3, because we have to find like this 2 to the power 3 equals 8. Okay, so this 3 will be our octal value. Okay, so now let us find how this actually works. So for that matter, if we have 4 inputs, these are the 4 inputs. So I0, I1, I2, I3. We have 2 outputs. Okay, O0, O1. These are the 2 outputs. So it could be represented as 4 to 2 encoder. Okay, this could be represented as 4 to 2 encoder. Okay, so now let us now jump on to this decimal to binary encoder. Okay, now let us consider the truth table of this decimal to binary encoder circuit. Here is the truth table. The thing that need to be addressed are, at any point of time there are no 2 bits that are high. That means in any rows, in every row there is 1 bit that is high and rest are all low bits. See, for example, at this point nothing is high except this one. At the row 2, nothing is high except this one, and so on. So we have given the n inputs, and at every point of time only 1 bit is high, and corresponding to that bit we have this 4 combination of bits. Okay, now what are the things that actually happens over here? If we give 1 here, no outputs will be selected or no outputs will be high. So for I0 nothing is gonna happen. For I1, this 1 will be lit up. So this O0 will lit up. For I2, this O1 will lit up, and so on, because what we can see is that for 2 in decimal we write 2 as this, and in binary what we do, we give 1 0. In 4-bit combination we give 0 0 1 0. So if we can consider I2 here, and if you can consider the 4 bits, we are 0 0 1 0, and this is I2. So we are actually nothing but representing this I2 or 2 in binary formats, nothing else. Simple logic, nothing else. So now what happens in circuit? So how to find the circuits from this output section? Now if we have this output as 0 0 0 0, so actually how we will send this, the output, as we will send this in O0, O1, O2 and O3, not this in these formats, but in these formats. Okay, now we have to consider these output sections. So if we can consider O0, what are the input signals that so if we consider O0, what are the high signals that we are getting? We are getting alternative signals, that is 1, 3, 5, 7, 9. If we can go like this, it is 1, then there is 3, then there is 5, then there is 7, and then there is 9. So we can consider it as I1 or I3 or I5 or I7 or I9. Okay, for O1 what we have we have this and this. So these are nothing but I2 and I3. This is I2 and this is I3, and this is I6 and I7. So I2 or I3 or I6 or I7. For O3, for O2, what will happen? So for these four, we have O2. So these are nothing but I4, I5, I6 and I7. I4, I5, I6, I7. Okay. And for O3, what happens? We have these two. That is I8 and I9. So if we can plot these into circuit, we will get the actual circuit. So I0. So now I0, I1, I2, I3, I4, I5, 6, 7, 8, 9. Okay. And we're gonna extend this like this. Now for I0, we are getting I1, I3, I5, I7, I9. Okay. So we are taking I1, okay, I3, I5, I7, I9, and we are adding this. This is O0. Okay. For O1, what we have? I2 and I3, I6 and I7. So we have I2, I3, I6, I7. For O2, what we have? I4, I5, 4, 5, I6 and I7. And for O3, what we have? I8, and so this is the truth table of decimal to binary encoder, and this is our circuit diagram for decimal to binary encoder. Okay, now we will move on to octal to binary encoder. So now we are in octal to binary encoder. Here we have 7 inputs and 3 outputs. So now what we have not seen or heard about, actually what I meant with only one inputs to highlight in input section and other will be off. This is like this. When we have to find, say for example, this 56 through the encoder circuit, what will actually happen? It will divide these numbers into 5 and 6. Okay, the 5 can be represented in 3 numbers, that is 101, these 3 bits, and 6 can be represented as 110. Okay, these 3 bits. So these 3 bits will be sent via these output sections, and this 5 can be over here. So this is what the 5 looks like. So this is how 5 looks like. So the 5 will be here. This combination will be sent, not actually this combination, but these combinations will be sent, but actually this will be sent based on our 2 to the power values. And after that, once this sending is over, then we will send this 6, not simultaneously. Okay, so what we have in O0. So in O0 we have in the interleaved combinations, that is 1, 3, 5, 7. So I1 or I3 or I5 or I7. O1, what happens? These and these. Okay. So this is I2 and I3 and I6 and I7. And in O2, what happens? These four. Okay. So these are 4, 5, 6, 7. Okay. So now how the circuit will look like? So for O0, what will happen? I3, I5, I1, I3, I5, I7. So I3, I1, sorry, I1, then I3, then I5, then I7. Okay, sorry. Now this O1 will I2, I3, I6, I7. Okay, so I2 over here, I3 is here, I6 is here, and I7 is here. And then now O2, I4 is here, I5 is here, I6 is here, and I7 is here. In both the cases, this I0 will be left over. So this is how our encoder actually performs and works in different circuits for different input combination.